Section 11.4a is about the Pythagorean Theorem. Before we get into the theorem itself, there's a couple of terms we want to get out of the way. In a right triangle, now a right triangle, there's a picture of one down here. A right triangle is a triangle that has an angle that's 90 degrees. If you have one of those, then the side that is opposite the right angle is called the hypotenuse. So if it's opposite, if it's across from the right angle, it's called the hypotenuse. This is the longest side of the triangle. And then the other two sides of the triangle, the two sides that are shorter than the hypotenuse, those are called the legs. So these terms set up the building blocks for what we're going to learn about the Pythagorean Theorem. Now the person that's credited with the theorem is called Pythagoras. He was a Greek mathematician, and the reason it's called the Pythagorean Theorem is because it shares his name. He found the relationships, he discovered it, and so he named it after himself. But here's what the theorem says. Basically it says this equation. It says that you can add the two short sides of a triangle, in this case called A and B. You can square those and then add them, and those lengths will equal the longest side. In this case it's called a C. So if you square the longest side, that will be equal to the square of the other two sides added together. Now the reason this works is because it has to do with areas, and if these sides were the sides of a square that had areas. So I'm not going to get into that specifics about why the Pythagorean theorem works, but understand that this is the formula that we're going to be using. So let's examine it here by looking at this example. C is the measure of the hypotenuse, so we're told that the C here is the longest side, and then we want to find the missing measure. Well, it turns out that we want to find the C here. So I'm going to start by just rewriting the Pythagorean theorem. Then I'm going to plug values in. I'm told the A is a 7, so I'm going to go 7 squared. I'm told the B is a 24, so I'm going to go 24 squared, and then I don't know C, so I leave it like that. So now let's square both of these numbers. 7 squared is 49, and 24 squared is 576. Adding those two together, you're going to get 625, and that equals C squared. Well, my goal is to find the measure of C, and not C squared. So how do we get rid of a square? Well, we use its opposite, which is a square root. So C equals the square root of 625, which if you know that, or if you have a calculator, you can find out is just 25. So we would say the measure of the hypotenuse of this triangle is 25. Now notice something that I didn't include. We've always learned that when you take the square root of both sides of an equation, you're supposed to include the positive and the negative. And I could have done that here, but remember, we're being asked for a measure, and measures cannot be negative. Distances cannot be negative. So we know that the answer here is going to be a positive 25. Here are some more examples just for us to work with the Pythagorean theorem. We're given three sides, or at least we're given two sides, and we have to find the measure of the third. So here we're given the longest side, which is the C, and so I'm going to plug in 29 squared equals A squared, but we're not given A, so that becomes my variable, my unknown, and then I'm going to plug 20 in for B. And now we're just going to plug and chug. We're going to do the algebra and try to solve for the A, just working with the Pythagorean theorem. 29 squared is 841. Certainly you can use a calculator for that. 20 squared is 400. Isolating the A squared, I'm going to subtract 400. So you're going to get 441 equals A squared. To isolate the A, we take the square root of both sides. And if you take a calculator and you take the square root of 441, you find out your answer is 21. So one of the legs of this triangle, given these two other sides, would be a 21. Over here, start with the Pythagorean theorem. C is 3 root 2, which I'm going to square. A is a 3, and I don't know a B this time. So 3 root 2, when you square that, you have to include the square in both of those numbers. So 3 squared is 9. Square root of 2 squared cancels, gives me a 2, so that's going to be 18. 3 squared is 9, and that plus B squared. Now I'm going to subtract 9. So 9 equals B squared. Take the square root of both sides to isolate the B, cancel those out. So B equals the square root of 9, which is 3.